Hello. Basically, this video is the answer of my promise to you guys in the tutorial session because there are some questions that has not yet to be answered. But I also think that maybe I will redo the question in the tutorial because it will have because we got some technical problem that at that time and also some other question that I think needs to be reviewed about. So let us begin. So we will answer these four questions. There are two from chapter 11 and two from chapter 10. So let us begin. Okay, the first one is, I think, is the hardest one of all four, and it is asked by you, by Jack, in the session. Basically, the question is find all the solution of the x such as this series becomes 0. Okay, that's it's turned out to be quite hard. So as you can see, this series can be written as the summation from 0 to infinity of x power to the n over 2n factorial. Okay. From the table, we look some series that quite similar to this one. That is, so it's look like cos x, because cos x is summation from n 0 to infinity minus 1 power to the n x power 2n over 2n factorial. Okay, factorial. So now if we have cos of square root of x, it's become summation from 0 to infinity minus 1 power to the n x power half power to n over 2n factorial. It's turned to be summation from 0 to infinity minus 1 power to the n x power to the n over 2n factorial, which is extremely like our question, extremely similar. Okay, the only difference is we have minus 1 factor of minus 1 here. So how about if we modify it a little bit here, so it's become cos of square root of minus x. Wait a minute, maybe you ask, can we do this square root of minus x? What does it even mean? Well, I will argue that we can do that. Remember the hint. Consider the cases when x is positive and negative. So actually, this one is kind of similar. The cos square root of x is only valid for x positive, right? So this equation cos of square root minus x is also valid for x smaller than 0. Okay, smaller or equal doesn't really matter here. For x negative, it's all become the inside will become positive, and that's become our normal equation. And this one will become summation from 0 to infinity minus 1 power to the n minus x power to the n over 2n factorial, which is the same as sigma minus 1 power to the n times minus 1 power to the n xn over 2n factorial summation from 0 to, now this is important because we want to avoid infinity, because infinity one power of infinity is quite messy. So let's say to the a, but here we have limit a to the infinity, so it is safer this way. So this limit will handle the infinite case. This one's become, so this one is actually the same as 1 power to the a, which is equal to 1. Okay, so this one become 1, so it's become summation, and from 0 to infinity 1 times x power to the n over 2n factorial, which is exactly the same as our initial problem, although it's feel a little bit illegal, but it is fine. Now, so we need to find x such as cos of square root minus x equal to 0. Okay, so we have here cos of square root minus x equal to 0, which means that when we will be cos equal to 0, the square root of x must be equal to pi over 2 or what? Or 3 pi over 2. So it is square root of minus x, not square root of x. Square root of minus x equal to pi over 2 or 3 pi over 2. So we have, well, basically square root of minus x is the same as, because the difference is pi, right? Only 1 pi, so we can write that minus x, square root of minus x equal to pi over 2 plus or minus doesn't really matter here because we will square gains, but let's say minus k pi for k equal to 0, 1, etc. Doesn't really matter. You can write plus, you can write minus, because later we will square. Well, now we will square both sides, so we have minus x equals to pi over 2 minus k pi square. So x become minus pi over 2 minus k pi square, which let us check once again should be fine because this one square must be positive and minus square, so it must be negative, so x is negative. So this is our answer for this question. So the second question is relatively easy, but there is some point that I like to talk about, and it was asked in the tutorial session, so let us do this. So find the arc length of this parametric equation. So I think everybody remember that basically the answer, the formula will be integral from 0 to 3 of square root 1 plus dy dx square dt. Okay, now we know that dy dx equal to dy dt over dx dt, which is the same as this is of dy dt is minus 2 over dx dt is a exponent t minus e exponent of minus t. Okay, that's quite easy. So dy dx squared is become 4 over e to t minus 2 plus e minus 2t. Okay, that's not hard. So this one become integral of 0 to 3 square root of 1 plus 4 over this part e to t minus 2 plus e minus 2t dt, which is 0 to integral 0 to 3 square root of what? E to t minus 2 plus e minus 2t plus 4 over e to t minus 2 plus e minus 2t dt became square root of e to t minus 2 plus 4 plus 2 plus e minus 2t over e to t minus 2 plus e minus 2t dt. Now one of your friend a little bit forget that it's actually looks similar. So if it is actually square root of this thing, sorry, so this one is square root of et plus e minus t, so it is the same as square, not square root, square of et plus e minus t square over et minus e minus t square dt. So that things become 0 to 3 et plus e minus t over et minus e power of minus t dt. Now we have what? Suppose u equal this part, et minus e to the power of minus t. So du dt will be et plus a minus t, right? So this is the du dt is the upper part. So in order to avoid problem, I will change this problem into indefinite integral. So it's become plus a minus t over a t minus a minus t dt equals to integral of u, because u is here, the bottom part, u over du. So it's become log natural of u. So now that's the same as logarithm natural of exponent t minus a exponent minus t from 0 to 3. So it is the same as then to the 3 minus a minus 3 minus limit t to the 0, because if we input 0 here, it's become ln 0 and it is not nice. So ln a to the t minus t, or the same as ln to the 3 minus ln limit t to the 0 e of 2t minus 1 over a t ln b3 minus a minus 3 minus, by L'Hopital we know that it is become 2, and so it is ln 2. So it's become ln. Okay. Okay, next problem is not exactly, so from the second problem, my point is, please review integration technique from last semester. Because it is important not for solving the chapter 10, not only chapter 10, even for chapter 11. So basically chapter 10 is not that hard, but ensure that integration technique from last semester has been already mastered well, otherwise it can be problematic. Next is, so, well, although the problem is looks short, but it is quite complicated actually. So basically, it is a circle with radius of 1, and this one is also a radius of circle. So there is a center of circle here, and we draw the circle something like this. Also, it's also this point also center of circle, and we draw the circle something like this, and yes, we draw it for 4 times. Sorry, yes, 4 times, and what we get is basically the question is how large this area in the middle. Okay, so it is actually the game of parametrization. So let us begin with the parametrization of the problem. We know from the circle has radius 1, so basically this is 0.1, this is, sorry, this is 1.0, this is 0. minus 1, this is 0.1, and this is minus 1.0. Okay, so we know now we draw a circle something like this, and this is the center of the circle here. So the radius here will be, this is 1, 1, so this is should be square root of 2. Okay, so what is the equation of this part is basically x square plus y square equals to 2, because square root of 2 square. Okay, now the center of this square is in the minus 1.0, so we put here minus 1, and this is minus 0. So we have the equation become x plus 1 square plus y square equals to 0, equals to 2. Now what we need to find is this look like something like this. This area, right? But for, as we see, we can divide this part into 1, 2, 3, 4, and every bit of this is a quarter of the problem. But this also, because of the symmetry, we can divide it moreover into 8. So basically I only find this area. This is the area that we will count in the integral. So now we try to change this into parametrization. As usual, x equals to r cos theta, and y equals to r sin theta. So this equation become r cos theta plus 1 square plus r square sin theta square equals to 2. Okay, by normal operation we have that it is the same as r square plus 2r cos theta minus 1 equals 0. Okay. If you don't believe me, you can prove yourself, but basically the same. So this turned out to be r equals to, using the normal ABC formula is minus 2 cos theta plus minus square root of 4 cos square theta minus 4 times minus 1 over 2. So this become minus cos theta plus minus square root of cos square theta plus 1. Because we only need to find area from this point to this point, pi over 4. So we will choose for r bigger than 0 is become r equals to minus cos theta plus square root of cos square theta plus 1. So this area, which is basically what 1 over 8 of the total area, the shaded area, is equals to, you remember the formula of the area is basically half r square d theta from 0 to pi over 4. So from 0 to pi over 4, which is what? Half 0 from 2 pi over 4. But we know here that r square equals to 1 minus 2r cos theta d theta. So we get here basically that a quarter of area equals to integral from 0 to pi over 4 1 minus 2 minus, what is r? R is here, minus cos theta plus square root of cos square theta plus 1 cos theta d theta. This long form is equals to what? Well, after a lot of manipulation, it is the same as 0 to the pi over 4 2 plus cos 2 theta minus 2 cos theta square root of 2 minus sine square theta d theta. So this thing will be the same as, well, zero to pi over 4. I separate those two, cos 2 theta d theta minus 2 0 pi over 4 cos theta square root of 2 minus sine square theta d theta. So this part is the same as pi 2 theta plus sin to theta over 2, 0 to pi over 4, and the left part is the same as 0 pi over pi 4 cos theta square root 2 minus the same as before. This one become pi half plus half minus 0, 0, so doesn't care, minus 2, minus this term. For this part, I will do substitution, that is t using t equal to sine theta, so d theta become cos theta. So basically it is cos theta d theta. So this part become integral of square root of 2 minus t square d theta, sorry, dt from what? From sin theta 0 sin pi over 2 half square root 2. So the integration of this part is the same as using the table, and we got it. It is the same as t over 2 square root of 2 minus t square plus arcsine of t square root 2 from 0 to half square root 2. So the answer is basically, the total answer is become pi over 2 plus half minus 2 times 2 minus half plus sine inverse of half. It's become pi 2 plus half minus half over 3 minus 5 over 3. So A become 2 pi of 3 plus 2 minus 2 square root of 3. So as we discussed before, the important part is, of course, the first one is how you can parameterize this picture. The other important part is how you can solve this integration problem. Okay, now the last problem, the fourth problem, is basically find the sum of the series. Look nice. So the series is same as summation from 1 to infinity of what? Minus 1 over 3 power to the n times 1 over 2n plus 1. Okay. Well, seems hard, but it's actually can be written as something like this. Summation n from 1 to infinity minus 1 over 3 power to the n x of power to n plus 1 over 2 n plus 1 when x equals to 1. Okay, how we solve this, we don't know, but suppose we differentiate this equation, dx. So this equation become summation from 1 to infinity over 3 to the n. It's the same of x of 2n, right? Which is look nice because it is basically a geometric series. So this one is the same as n is equal to 1 to infinity minus 1 over 3 x squared power to the n. Because it is just geometric series, so it is the same as, well, when n equals a1. Using this formula, we get minus 1 over 3 x squared over 1 minus 1 over 3 x squared. Basically, this is the same as minus x squared over 3 plus x squared. So basically what we get is this, but what we ask is not this, but the integral of this problem. So basically our original problem, summation n from 1 to infinity of minus 1 over 3 over to the n x power to n plus 1 over 2n plus 1 is the same as integration of minus x squared plus 3 plus x squared. Okay, good. Now, dx. But this part, it will be easier to solve if we write as minus 1 plus 3 over 3 plus x squared dx. Why? Let us see. Basically, integral of minus 1 plus 3 over 3 plus x squared dx. It will be the same as integral of minus x dx plus integration of 3 over 3 plus x squared dx. This one is easy. Sorry, this is minus 1, not minus x, minus 1. This one is easy, it's become minus x. This one is, well, when we look at the table, just from last semester, we got that this is equals to 3/3 tangent of x/3. Tangent inverse x/3 plus c plus tangent inverse x/3 plus c. So now we have the original equation. This part is basically summation from n(1) to infinity minus 1 over n to n plus 1 3n to 3 power n is the same as minus x plus tangent inverse x/3 when x equals to 1, which is minus 1 plus tangent inverse 1/3. Find in the calculator or just leave it that way. So I think that's it for the fourth problem. So my point is, even though it's just a summation, you still need to master integration technique. Okay, thank you. See you soon.